Hi, my name is Dave Brown and I'm the Vice President for Amazon EC2. I'm excited to be with you today to kick off our first ever AWS Silicon Innovation Day. I've been with AWS since 2007. I started as a software engineer on our EC2 team in AWS's Cape Town office when we were launching our very first EC2 instance. There were about 14 of us on the team at the time, and I don't think any of us had any idea that AWS would grow to become what it is today. Since day one, two things have driven us. First, providing customers with tools and services to securely and reliably run virtually any workload. And second, delivering customers with more performance at a lower cost. As the demands of cloud computing grew over the years, and as customers presented more challenging problems for us to help solve, we realized that we had an opportunity to innovate on behalf of our customers by developing our own custom silicon optimized for the cloud. Today, I want to talk to you about silicon innovation at AWS and how the silicon we develop, in turn, has made it possible for our customers, from the smallest startups to the largest enterprises, to innovate for their end customers in ways that were previously unimaginable. When we first started, there was no precedent for what customers might need or want, but we knew we were designing to solve two critical needs. The first, customers would want to scale their infrastructure up and down based on demand. And second, customers would want to only pay for what they used. And so we created the first EC2 instance. We were so far ahead of our time that no one had done this before. We launched a single instance based on an educated guess around what customers might need, and we figured we could just run more of them in parallel to support larger workloads. We called it the EC2 instance. Later, we realized customers were going to need different sizes of instances for different workloads. We eventually named the instance the M1 Small because we needed to introduce the M1 Large with more memory, compute, and storage. Almost immediately, we started to see customers use instances in ways we had never expected, and those new use cases pushed us to innovate to address their needs. Today, we continue to deliver innovations to help ensure customers can meet those two critical needs: a desire to scale the infrastructure as needed and only pay for what they use. We've come a long way with EC2 over the last 16 years. AWS has seen incredible applications that customers have built and are building on EC2. As we learn from customers, we strive to build better, more diverse, and more capable instances to support every possible workload, power new customer innovations, and better help customers tailor infrastructure to their workload needs. So why did AWS start developing our own silicon? Well, back in 2006, when we got started, we used Xen to emulate the hardware we exposed to the guest operating system. At the time, para-virtualization was a great way to make what we considered performant VMs. However, as we listened to customers, we quickly realized that if we wanted to continue to innovate at the pace they required, we had to think differently. After spending years of optimizing traditional virtualization systems to the limit, we knew we had to make a dramatic change to the architecture if we were going to continue to increase performance and security for our customers. If we wanted to deliver more performance, lower latency, and increased scalability, we needed to address the resource constraints that were needed to perform the virtualization itself. Now, at the time, up to 30% of the CPU was still being used for virtualization and I/O, instead of being used for customers' workloads, which actually is how most cloud providers still operate today. Wanting to improve the efficiency of our virtualization and I/O architecture was the spark that led us to create the AWS Nitro System and initiated the process of AWS designing our own silicon. We started developing this new architecture at AWS in 2012, and by 2013, we released a new feature for EC2 called Enhanced Networking, along with the C3 instance. You can consider this the first iteration of our Nitro system and the first introduction of AWS-designed silicon. As we iterated on this hardware, we started working with a startup out of Israel called Annapurna Labs. We were really impressed with both their people and their technology, and so in 2015, we asked them to become a part of Amazon. We continued to work closely with Annapurna over the years to further improve the Nitro system by breaking apart virtualization functions, offloading them to dedicated hardware and software to deliver practically all of the compute and memory resources of a server to run customer instances. Since then, the scope of Nitro has expanded and has become the underlying architecture that powers all modern EC2 instances. Today, Nitro handles everything from storage access to encryption, networking, monitoring, and security. The Nitro system and its corresponding silicon is unique to AWS and impacts each of our customers in three important ways: performance, security, and innovation. Let's talk about how the Nitro system impacts performance. Ever since we saw the amazing thing customers were building on EC2, we've been striving to build better, more diverse, and more capable instances to support every possible workload and to power new customer innovation. Customers were asking for bigger and faster compute instances. They wanted more memory, faster CPUs, more networking throughput, and persistent disks. With the Nitro system, all of these functions are offloaded to dedicated AWS-developed Nitro cards, enabling high-speed networking, high-speed EBS, I/O acceleration, in addition to delivering practically all of the compute and memory resources of the host hardware to customer instances, resulting in better overall performance. In order to gauge the true performance of an instance, you can't just focus on the baseline CPU benchmarks. You need to see how all of the components work together to meet the demands of the workload. When you test real-world workloads such as web servers, databases, and video transcoding applications, you can see the significant performance benefits that AWS Nitro provides. Nitro was custom designed and built by AWS from the ground up to scale for the most demanding workloads. With the AWS Nitro system, Amazon EC2 instances deliver up to 10% higher throughput than other major public cloud providers, running the same CPU, with up to 25% higher throughput on some workloads. Our Nitro System innovations have allowed us to deliver even better performance to customers. If you think about the numbers I just provided, that is almost the equivalent of a generational improvement in performance just by using the AWS Nitro system. And we don't just stop with performance gains. The Nitro system is also designed to meet the highest security requirements from AWS customers. As we think about security, there has been an increasing interest in the phrase confidential computing, both in the industry and in our customer conversations. Definitions vary, but it ultimately points to a greater interest in data privacy and control over where your data goes and who has access to it. The term confidential computing might be new, but our approach to user security and privacy is tried and tested. We found that customer questions around confidential computing fall into a few distinct categories. How is my data protected from the cloud operator? That's us. How is my data protected from other applications running on the same host that I don't control? And how is my data protected from less trusted parties within my company? We engineered the Nitro system from a hardware-based root of trust using the Nitro security chip, allowing us to cryptographically measure and validate the entire system. This provides a significantly higher level of trust than can be achieved with traditional hardware or virtualization systems. Today, Nitro is a rich collection of building blocks that can be assembled in many different ways, giving us the ability to innovate more rapidly. Our customers benefit from the value that Nitro provides through our broad selection of new EC2 instances, rich features, and enhanced security. Because new EC2 instances are based on the Nitro system, we can design and deliver new instance types with an ever-broadening selection of compute, storage, memory, and networking options far more quickly than we ever have before. We're also able to use the unique design of the Nitro system to offer innovations otherwise not possible, such as bare metal instances, VMware Cloud on AWS, AWS Outposts, and even EC2 Mac instances. It's thanks to the Nitro system that we're now able to offer over 500 different instance types, so you can run virtually any workload with the performance and price that aligns to your business needs. Our Nitro cards use custom ARM-based chips designed by AWS. Once we realized some of the advantages those chips gave to us, we started to think about how we could make that available for our customers to use for more general purpose computing. Up until this point, ARM was still mostly used in mobile processors and single board development computers. It hadn't yet been available at scale inside the data center. The Nitro system was the start of AWS's Silicon Innovation, and our investment in silicon soon expanded to other areas. As customers continued to bring more diverse workloads to the cloud, we saw the opportunity to bring an AWS-designed processor to the market to help customers further reduce costs and achieve better price performance in the cloud. Our first processor, the AWS Graviton Processor, was announced at reInvent 2018 and was delivered to market as part of our EC2 A1 instance targeting scale-out workloads. Thousands of customers have adopted A1 instances and provided feedback that they wanted to run a more broad set of workloads on Graviton-based instances that required more compute power, more memory, increased networking and EBS performance, larger instance sizes, and even more capabilities. To meet this customer demand, we announced AWS Graviton 2 processors the following year at reInvent 2019. Graviton 2 processors provided 7 times increase in overall performance compared to the first generation AWS Graviton processors and offered 4 times the number of compute cores, 5 times faster memory, and 2 times larger caches. Furthermore, Graviton 2 processors feature key capabilities that enable developers to run cloud-native applications with additional security and at scale, including always-on 256-bit DRAM encryption and 50% faster per-core encryption performance compared to first-generation Graviton processors. Today, we have delivered 12 different Graviton 2-based instance types across 23 regions globally that enable customers to run a broad range of workloads, including general-purpose, compute-intensive, memory-intensive, storage-intensive, burstable, and accelerated computing workloads. Tens of thousands of customers from startups to large enterprises, including DirecTV, Epic Games, Formula One, Intuit, Nextroll, SmugMug, and Snap, have realized up to 40% better price performance gains with Graviton 2-based instances in production. In addition, many customers are using AWS services like Amazon Aurora, Elasticache, Elastic MapReduce, Lambda, and Fargate that support Graviton and are seeing similar benefits as well. In fact, today, 48 of the top 50 Amazon EC2 customers by usage run workloads on Graviton 2-based instances. Databricks is one such customer. Databricks is the world's first and only lakehouse platform operating in the cloud. After recognizing their customers can obtain up to 2 times or even 4 times performance improvements over other Amazon EC2 instances this past April, Databricks announced support for AWS Graviton 2-based instances used with Photon, their high-performance Databricks query engine. This is a great example of how partners continue to see ways to leverage our Graviton performance for their own customers. Graviton 2 has been a huge success for AWS and a big win for our customers trying to get the most performance for each dollar of spend. But as you know, customers always want more. And so earlier this year, we launched Graviton 3. Graviton 3 processors provide up to 25% better performance compared to Graviton 2 processors, with up to 2 times higher floating point performance, up to 2 times faster cryptographic workload performance, and up to 3 times better ML workload performance. Graviton 3 processors also support the latest DDR5 memory that provides up to 50% more memory bandwidth as compared to DDR4. Just like Graviton 2, Graviton 3 processors are also highly energy efficient and will enable our customers to reduce their carbon footprint in the cloud. Graviton 3-based instances use up to 60% less energy for the same performance than comparable EC2 instances. The first instance to utilize Graviton 3 processors is our new Amazon EC2 C7G instance, which provides the best performance in Amazon EC2 for compute-intensive workloads such as high-performance computing, batch processing, electronic design automation, gaming servers, media encoding, scientific modeling, distributed analytics, ad serving, and CPU-based machine learning inference. I've spoken about the introduction of our Graviton-based silicon and mentioned there has been tremendous customer adoption. I think nothing tells the story of adoption better than talking to you about some of those customer success stories. Millions of people across the globe trust SmugMug to host their photos and videos. SmugMug is not just a leader in shaping the future of photography, they're also a leader in cloud adoption. For more than 15 years, SmugMug has run their business on AWS. When AWS launched our first generation of Graviton processors, SmugMug's team told us it took longer to upgrade the latest version of the operating system on x86 than it took to adopt the AWS Graviton processors. Since then, SmugMug has adopted Graviton 2 and has already begun adopting our latest Graviton 3 processors. SmugMug's chief geek and CEO Don McCaskill told me it took them a single day to migrate to Graviton 2. And with our Graviton 3 introduction, Don described our Graviton 3 instances as smoking fast. And we now are seeing even more customers choose Graviton to power many of their mission-critical enterprise business applications. Take SAP, for example. At reInvent 2021, they announced they would be porting SAP HANA Cloud, their in-memory database as a service offering, to Graviton. HANA Cloud provides the database foundation for many of SAP's products, including the Rise with SAP offering. SAP believes moving to Graviton will enable performance and efficiency improvements for our shared customers. SAP is also a signer of the Climate Pledge Agreement and shares AWS's goal of helping customers run their applications sustainably. Graviton's power savings can help play an important role in achieving sustainability goals. Graviton has been very popular with many of our customers. Some customers have gone all in on Graviton-based instances. Honeycomb is one such customer. As of April this year, Honeycomb has migrated their entire EC2 fleet to Graviton 2 and Graviton 3 instances. Not only has Honeycomb taken advantage of our Graviton 2 and 3 instances, they are also leveraging our Nitro SSD-based instances, IM4GN, which help improve latency, and something I'll talk about a little bit later. Part of the success of Graviton has been ensuring that adoption would be easy. We want all of you to take advantage of the innovation AWS has delivered to customers using our silicon. This year, we're making adopting Graviton even easier by introducing the Graviton Fast Start program. This is an evergreen initiative that makes it even easier for customers to get started with Graviton-based instances, whether it's through our managed services or directly through EC2. Customers such as Wealthfront use our Graviton-supported EMR managed services to get similar price performance benefits as using Graviton-based EC2 instances, but in much less time. Through this Fast Start program, we will offer customers step-by-step plans on how to use Graviton through some of our popular managed services, such as Lambda, Fargate, and Aurora, and achieve the 40% price performance gains in as little as 4 hours. And for those who prefer to use Amazon EC2 directly, we still offer the 4-day step-by-step plan as well. We also have a free trial on Graviton-based T4G small instances for up to 750 hours per month through the end of the year. I want all of you to take advantage of this opportunity to try out Graviton. Since we introduced the first generation Graviton processors back in 2018, each new generation has been a huge leap forward for our customers in terms of performance, price performance, as well as the workloads supported. Within just 4 years, we've rapidly innovated and introduced 3 generations of Graviton processors, simply an amazing pace of innovation. While developing our Graviton processors, we received customer feedback about a need for a similar silicon innovation in the machine learning space. We wanted to focus on delivering ML chips to help with the 2 biggest components of machine learning. First, training, the process of teaching your model how to perform a task, and second, inference, the process of deploying the model and leveraging the trained model to assess real-world data. With 90% of the operational cost of building and running machine learning coming from inference, we saw a huge opportunity to lower the cost of ML for the masses by first focusing on inference. Our vision is to make machine learning pervasive for everyday developers and to democratize access to cutting-edge infrastructure made available at a low-cost pay-as-you-go usage model. Our first ML chip, AWS Inferentia, is designed and built from the ground up to provide high-performance inference in the cloud, to drive down the total cost of inference, and to make it easy for developers to integrate machine learning into their business applications. With Inf1 instances that are powered by the Inferentia chips, we're able to deliver up to 70% lower cost per inference than comparable GPU-based Amazon EC2 instances. Since the introduction of Inferentia at reInvent 2019, customers including Airbnb, Anthem, Autodesk, Condé Nast, Snap, Sprinklr, and even our own Alexa are seeing huge benefits from Inf1 instances. Let me tell you a little bit about Autodesk. Autodesk is using Inf1 instances for their chatbot, Ava. They were able to quickly and easily integrate Inferentia with only a line or 2 of code, and practically overnight saw their cost performance rate increasing 5-fold. This means a company like Autodesk is able to serve 5 times as many people for the same cost, or launch 5 new models on the same budget they had before migration. That means even better ML performance. On the machine learning training side, we have AWS Trainium, our second custom ML chip. As deep learning models become more complex, businesses grapple with the exponential increase in time and cost to train them. Amazon EC2 TRN1 instances are purpose-built for high-performance, cost-effective deep learning training for applications such as natural language processing, speech recognition, image recognition, fraud detection, and recommendation engines. This means that you can train more with the same budget or save up to 40 to 50% while getting best-in-class performance. TRN1 instances are powered by up to 16 AWS-built Trainium chips, which have hardware optimizations for a wide range of data types including configurable FP8, dynamic shapes, and C++ custom operators. They have Neuron Link, an ultra-fast connectivity between Trainium chips, and 800 gigabits of networking bandwidth, which is the highest we've offered in AWS Cloud for multi-node distributed training. We're also building TRN1 Ultra clusters at a massive scale with non-blocking petabit scale network, so you can have on-demand access to one of the largest machine learning clusters in the world. You can get started easily with just a few lines of code changes using leading ML frameworks and libraries, as AWS Neuron SDK integrates with them seamlessly. Furthermore, many of our tools and managed services also support training your models on TRN1. Once trained, you can deploy your models on the hardware platform of your choice. TRN1 instances can help you innovate faster by reducing time and cost to train. We can't wait to see what you build with it. Another area where we saw opportunity for innovation in recent years was storage. So we wanted to see how we could extend Nitro to improve storage performance as well. Customers have asked AWS to provide them with better local storage performance and more granular control over features they use to tune their application settings. We knew that to deliver these innovations for customers, we would need to take tighter control of the storage hardware, as well as the firmware and drivers. Using our experience in developing silicon, we started to work on delivering innovations for our customers as well. We wanted to produce high-performance, low-latency SSDs that would provide much better IOPS and lower I/O latencies. The result is what we call the AWS Nitro SSD. As the name implies, Nitro SSDs are tightly integrated with the AWS Nitro System. Nitro SSDs are NVMe-based and enable significant improvements in IOPS and latency performance. Up to 60% lower I/O latency, in fact, over commercial SSDs, and reduced latency variability by up to 75%. With Nitro SSDs, AWS can now optimize SSD performance for specific I/O-bound applications and offer leadership storage capabilities to further accelerate I/O processing to maximize the price performance of customers' storage workloads. Nitro SSDs are now available in 3 instance families: i4i, IM4GN, and IS4GEN. Customers including Redis, Splunk, and Sprinklr are using the AWS Nitro SSD-based instances and seeing great success. One story I like sharing about Nitro SSDs is Splunk. Splunk is a leading data platform provider, allowing customers to investigate, monitor, analyze, and act on data at any scale. In their testing of the new storage-optimized Graviton 2 and Nitro SSD-based instances, IM4GN and IS4GEN, they found that it reduced the cost of their search runtime by as much as 50% compared to previous generation instances that we were based on alternative SSDs. That is truly astounding. Today I've shared with you examples of customer successes for many of our silicon innovations, and I wanted to finish with a final customer story from Sprinklr. Sprinklr provides a unified customer experience management platform. It is a cloud-first company which is always looking to improve their efficiency, provide better performance, optimize cost savings, and of course provide their customers a better overall experience. Sprinklr is a customer that utilizes and benefits from multiple AWS Silicon Innovations, including Graviton, Inferentia, and Nitro SSDs. On the ML side, Sprinklr uses Inf1 instances to significantly improve the performance of their natural language processing and computer vision models. With the better performance, they're able to reduce latency of their products and services, which in turn mean a better customer experience. Additionally, the introduction of Nitro SSD-based instances, which are focused on reducing latency variability, create an additional opportunity for Sprinklr. By moving their storage-bound workloads to Graviton and Nitro SSD-based IM4GN instances, they were able to see a significant 50% reduction in latency for queries, as well as a significant 40% price performance benefit. For Sprinklr, moving to AWS Graviton 2-based instances was easy, taking just 2 weeks to complete benchmarking. It's simply awesome that we're able to have such an impact on customers like Sprinklr, as well as others mentioned today. By designing and building custom silicon, AWS is able to deliver innovations for our customers. We have a full day ahead that we hope is both educational and inspirational. Today we'll share more about the details of our silicon innovation, deep dive into specific technologies, and I highlight how our customers have benefited and innovated for their own customers. I talked about a few customers who have taken advantage of many of these instances. I want to encourage all of you to try out AWS Silicon Innovation for yourself. One easy way to do this is to try the Graviton Fast Start program and see how easy it is for yourself to get better performance while reducing costs. Thanks for joining me today and for participating in the Silicon Innovation Day.